Good morning to all. As the previous class, we talked about what is the digital system, what are the various types of digital systems, and how to solve a real world problem, and one example of bank test, etc. was seen. As a continuation, we would like to take some real world problems and see how the control expression is going to be obtained. So, digital system applications we are primarily focusing in this class. We are primarily focusing digital system applications. One by one we take it. First application we consider it. If you want we can make it as 1. Recap quickly, and what is the process of solving the real world problem? Identify the system to solve the real world problem. What is the meaning of identify system? You have to select the inputs as well as associated outputs for the concerned problem. So you have to represent that problem as a system, and the system is associated with the inputs I and the output Y. It can be single input, single output, multi input, single output, multi inputs, multi outputs, multiple, as usual. That's 4 cases: single input, single output, single input, multi output, multi input, single output, multi input, as well as multi output. So this is what you have to identify. Then the behavior of the system is going to give some kind of clue. Using that, you should construct a truth table. The truth table is associating with all possible input output combinations. So it is primarily reflect the behavior of the system. And we now extract the Boolean expression from this truth table. That means what is the control expression for that problem or for that system, and we devise it or extract it, and we call that as a Boolean expression. And we solve this Boolean expression with the help of a hardware, and this is going to tell what is to be performed, and it won't do what the action. And hence we take the help of another electromechanical gadget, we call it as actuator, which will perform the actual work. A simple one is temperature control in a furnace. So here each furnace zone must maintain specific temperature. If it is high, it is going to damage the system. It is low, it is not able to perform that work, etc. Okay, as usual, the flow is very quick. The analog inputs of the real world problem are taken and they are converted into digital using A to D converter. These digital inputs are going to be used for devising the truth table. And once that Boolean expressions are there, we have to use the hardware for solving this Boolean expression, and it is going to tell what is to be done, and hence the answer of this will be either 1 or 0. 1 means perform some action, 0 means not perform the action. So it will take the help of the other gadgets. We call it as electromechanical devices, devices that in turn will do the action. That action is going to either increasing the temperature or reducing the temperature, etc. Assume that the temperature is more than the threshold value, then the furnace has to activate the cooling system, that is the fans or the coolers, so that the rise in the temperature is getting arrested. Or if the temperature is less than the required value, then it's going to raise the temperature by properly adjusting again the cooling mechanism. It will allow not to cool too much, etc. Is it clear? Temperature control in a furnace. The second one, we take it as headlight warning system. We will give in-depth analysis of this headlight warning system, etc. This headlight warning system is basically for the, like, let us say, a four-wheeler. It can be a car, and there will be a headlight. Okay. So this headlight should not be unnecessarily on or should not be off when it is desired. Should not unnecessarily on or should not off when needed. Should not off when needed. Oh, more than anything else, it's a common sense tells us when the headlight is required and when the headlight is not required. It was proven that, or it is known to us, when we are driving the vehicle in the day, we don't require any headlight. Hence, headlight should be off mode. When you are driving the vehicle in the night, obviously, headlight has to be on. Okay. So, what is meant by warning? When anything is violating these requirements, warning is to be given. Whom it should give the warning? Obviously, to the driver, and driver will take appropriate action. This system, y equal to output is y. If it is 1, warning is given. If it is 0 normal behavior, there is no warning. And we have seen one the several systems. We try to devise what could be the inputs and what will be the outputs of this system. So primarily the inputs of this system is a headlight status itself, and whether the engine is on or off, or whether it is day or night. So three components. One is the headlight, second is whether it is driving mode or non-driving mode, and the third one is obviously whether it is day or night. So three inputs are there: HID, headlight, engine status, and is it a day or night. And the behavior of this is going to be, we can take uh, the sample requirement. H is the headlight, which can be have the binary values either 0 or 1. So normally 0 means off and 1 means on. Then I, engine, it can be either 1 or 0. 1 means engine is on, 0 means engine is off. And day night sensor, D is 0 means it is a day driving, and if it is 1 means it is night driving. So we need to assign the boolean values to each of the inputs. Inputs are binary in nature. They can have only two values, two states. And as far as output concerned, it may say either warning is to be made or warning is not to be made. So this is HWS, headlight warning system. Okay, this is what we say. When headlight is unnecessary on, warning is to be made, and headlight was not on when it is needed, again warning is to be given. So it is having multiple inputs and single output system. We call it as a multi-input single output system. Many inputs, one output. So as already we discussed, H is 0 means headlight is off, H is 1 means headlight is on. Engine is status is 0 means it is off, I is 1 means engine is on. Day night sensor, if it is 0 means it is a day, and if it is 1 means it is a night. And D is 1 and I is 1 means it is a day and engine is on, simply denotes day. It is D is 1 means it is night, I is 1 means on, it is a night driving. D is 0, I is 1 means D is 0 is a day and I is 1 means engine is on, obviously it is a day driving. Night driving, headlight should on, H must be 1 for normal operation. And if it is a day driving, H must be off or it should be 0. Is the normal behavior. Anything violates it, warning should be given. So we try to construct the truth table for this system, behavioral table, and try to get the Boolean expression afterwards. Okay, this is the truth table. As that there are three inputs are there, H, I, D. These are the inputs of the table, and this Y is basically output, and collectively we call it as a truth table. This truth table for what? Headlight warning system. 0, 0, 0. And since engine is off, there is no need of headlight, and hence it is a normal operation, hence there is no warning. Again 0, 0, 1, engine is off, headlight is off, again it is a normal operation, hence there is no warning. 0, 1, 0, indeed the driving is made, but it is a day driving. H is 0, it's a day. 1 means engine is on, it's a day driving, and headlight is off for day driving. D0 means day, I1 means engine is on, it's a day driving, headlight is not required, and hence it's a normal operation, no warning is to be made. But see here, I is 1, vehicle is on, but it is a night, obviously it is a night driving, headlight must be on, but what is given? 0. So he says headlight is off, so it is not a desired one, and hence warning should be given. So warning given means Y is 1. Now we see the other combination, 1, 0, 0, headlight is on, vehicle is not drived, there is no movement in the vehicle, whether it is day or night, headlight is on means it is unnecessarily we are making the headlight on, hence warning should be given. So we are parking and simply headlight is on. Assume that not in the road, it is in the house. If it is in the house, everyone will complain. The headlight is on and it is parked. It's a nuisance for us and we need to take the proper control. Come back here. Vehicle is on and it is a day driving, but headlight is on. So for day driving we don't require headlight, but it was on, hence it is a violation, it's abnormal operation. The moment it is abnormal operation, Y has to be 1. And if it is 1, 1, 1, engine is on, it is a night driving, headlight is on, it's a normal operation, and hence no warning is made. So abnormal, warning is to be made, and for normal operations there is no warning. And soon we are going to see how to express a Boolean function or a Boolean expression for this problem. We can express, there are two ways of providing the Boolean expression. One is called the sum of product expression, another is product of sum expression. We want to say what should be the Boolean expression for this headlight warning system. From the truth table, we should derive it. So what you can do, you consider the input combinations for which output is 1. Or you consider the input combinations for which output is 0. So accordingly, we call it as sum of product expression, product of sum expression. The input combination for which output is 0, we call it as mean term input combination for which output is 1. So in this case, this is the one input combination for which output is 1. This is another input combination for which output is 1. This is another input combination, output is 1. This is another input combination for which output is 1. Hence, these are called as mean terms. Soon we are going to see what is the mean term and how to provide an expression for the mean terms. So on the other hand, the input combinations for which or input combination for which output is 0 is called as max term. So entire digital system is based on mean terms and max terms. So in this problem, there are 4 max terms and 4 mean terms. The max terms are this. This is the input combination for which output is 0. This is another input combination for which output is 0. This is another input combination for which output is 0. There are basically 4 places where output is 0. We call them as max term. So Boolean function can be written as either sum of product expression or product of sum expression. A sum is normally denoted with the sigma, product is denoted by pi. So in a very compact manner, how to describe the sum of product expression? We consider the decimal value for the input combinations where it is 1. 0, 1, 1 is obviously a binary pattern for which the decimal value happens to be 3. Output is 1. 1, 0, 0 is the input combination and output is 1. 1, 0, 0 is the binary pattern for which the decimal value is obviously 4. 1, 0, 1 is the binary pattern for which output is 1. 1, 0, 1 is converted into decimal, it will become 5. And 1, 1, 0, again the output is 1. 1, 1, 0 is the binary pattern. When converted into decimal, it is 6. Hence, what is the Boolean expression for headlight warning system is sum of product sigma 3, 4, 5, 6, and this we call it as y as a function of h I d. The other way we consider the max terms. The 000 for which output is 0, the binary pattern is 0, concerned decimal value is 0. 001 for which output is 0. 001 is the binary pattern for which decimal value is 1. 010 is the binary pattern for which decimal value is 2. And 011 output is 010 output is 0, hence it is a max term. 010 is a binary pattern for which output is 2. And finally 111 for which output is 0. 111 is corresponding to the decimal value. Binary is 111, concerned decimal is 7. Since it is a product of some expression, you simply write it as pi of 0, 1 to 7. So what will be the Boolean expression for it? It also can be written as pi of 0, 1, 2, 7. So interestingly, if 0 is present in max term, it cannot present in min term. If 1 is present in max terms, it cannot present in min terms. If 2 is present, it cannot present in min terms. If 7 is present, it cannot present in min terms. Like that, 3, 4, 5, 6 cannot present in max terms, or 0, 1, 2, 7 cannot present in min terms. So there are two ways of writing the Boolean expression. In broad, one is called sum of product expression, another is product of sum expression. For this problem, the sum of product expression is sigma 3, 4, 5, 6, or the product of sum expression is pi of 0, 1, 2, 7. Thank you.